Okay, okay, all right. So is there any difference?
No. I tried to change and the result is almost the same.
Okay, so maybe there's observation. Do you expected, right? Because sometimes students, they got the results, but they couldn't explain. All right, that's why when you in your final year later, when you are in third year, right, at the moment. So next year when you do your capstone or the final year project, there are results and discussion. All right, so you must be able to. Sometimes students got the good results, but they don't know how to explain. Is it expected? Okay, this is what I want you to think. All right, because next week we don't have any meeting, right?
Yes.
So next week you are going to do the project 4. So I meet a new student, but you need to prepare for the report. All right, for the group report. All right, so you have to think, is it the result you got is expected or not? Okay. And then you can see the operation. I want to see like 2 quadrant. You said this is 2 quadrant operation, right?
Yes.
During the forward and during the reverse. All right. Because here the input here, right? You can put the input something like the changing. I really don't know how to say. All right. Here you put 5, right? The constant, right? Here.
The constant, the L constant.
Yes. How about if you put like a sawtooth, like from 0 to 5 and then from 5 to 0?
The result may be changed and vary.
Yeah, of course. But we try to emulate. You try to see like the leaf, right? The leaf go one to the other. Like you can see here, this is the 5 here. What is it the speed or what? I saw here TL.
Speed. TL is
Top, right? Low top.
Top.
Yeah, but you try to imagine that you go to the elevator, right? Okay, let's say you go from 1st floor to the 5th floor. All right, maybe that is quadrant 1, and then from 5th floor to the 1st floor again, or maybe from 5th floor you go down to the 2nd floor. So it's other direction. How do you want to simulate that kind of behavior?
I change the sign of the top letter.
Yes, of course. Okay, all right. So we want to see how. Okay, so I think so. You are doing this one, and how about Firdaus? What are you doing?
Theory.
Theory, all right. Imran?
Do the separately excited.
So you got the same results?
A little bit different from the permanent magnet.
Is it expected? Adakah itu yang kamu jangka ataupun memang can you explain? Can you explain the results?
Okay. Okay, from 4 o'clock this morning. Okay, very early. Saya tak tidur lagi. 4 sampai berapa ni? Very tired. Okay, got very busy morning. Just now I got 2-hour class and then I have to do some things. Okay, so many busy. All right. Okay, from the from the permanent magnet, we can see that the armature current and electric torque is a little bit lower than the separately excited.
Okay, but you can see, right, the graph of torque and armature current, because you have to know. All right, T equal to K5 IA, right, for the permanent for the DC motor, right? Okay, I show you. Okay, wait. I show you something. All right, when you do the DC motor, okay, wait, I share. Okay, like I told you, okay, for the DC motor, can you see my screen?
Yes.
So for the DC motor, there are 2 equations, right? T equal to K5 IA, right? Okay, that means T berkadar kepada I, okay? And then you got E equal to what? K5 omega M, correct? These are 2 important equation for DC motor. Okay? So that means just now, where is it? So just now, is it Imran?
Yes.
Okay, just now I see your talk and current armature current waveform is quite logic. All right. So you have to explain how. Okay. Maybe you can look at the certain papers or certain simulation. Is it your graph? Is it as expected as the simulation from the other people work? All right.
Okay.
Okay, then you can see your results. Because sometimes students, I think they can present the results, but they cannot analyze or they cannot explain. All right. So maybe Firdaus can look into this area because you have done the theory, right? Maybe you can look at in the internet or in your Google around to see what is the typical waveform for the separately excited and permanent magnet. All right, from the theory and from previous work done by other people, the simulation done by Imran and Iqmal, so that later you can put in like a comparison, one side, the other side. Okay, this is the simulation from the other guy, this is your simulation. Does it agrees? All right. Sometimes they look similar, which is good, but maybe there are some waveform which very totally different. So maybe you have to ask whether your result correct or not. Okay, this is how you do. All right. Okay, I think you are done. So I want to say some last on project 2. All right, when I divide the group and this student they don't realize I was in the group, and then they tell me something like so many things. All right, they saying that this PBL lab takes so many times. All right, and then the marks is only not so much. Do you agree or not? Do you think this 3 weeks take so much from the other project, your project 1, project 2, or is it reasonable?
Reasonable.
Reasonable, right? Okay, reasonable. Okay. Okay, thank you, Group 8. I think you are doing very well. So Group 12, either Shakir or Yusuf, can you present something?
Yes, doctor.
Okay.
I do the permanent magnet DC motor.
Right.
Thyristor drive. We have to build
You're
a
doing
circuit. I use
FDR, right? Thyristor.
Yes, thyristor drive.
So you, by changing the angle, right? Changing the angle,
Yes.
you can changing the
Reduce delay.
input to the using permanent magnet or
Permanent
separately
magnet.
excited?
doctor.
Permanent magnet. Okay,
Permanent
all right.
magnet. Yes.
So can I see the waveform? Sorry, how about the parameters first?
The permanent magnet, I used these parameters because I wanted to have the same values as Shakir.
All right.
He used a preset values, so I just copy the preset
So
values.
Shakir, how do you get the value? How do you determine the values?
It's preset in
Preset.
MATLAB.
All right. Okay.
Yes.
So this one you got from the Simulink or you build by yourself or you got from other?
I built.
All right. Okay. So you got last time you got any problems when you want to run?
No.
All right. Okay. Good.
Actually, last time we even calculated the phase delay last time.
All right.
Let me
Okay.
check.
So let's say now we want to see what is the angle now.
Now we have the 36, which is 0.02 phase delay,
Okay.
and here we add 180 degrees, so it's 0.12.
Okay. So is it the result as expected? Can you run? I want to see.
Yes. This is the scope. This
Yes.
is our speed. This is the armature current, the overshoot, the steady state, and for the torque too.
How about the waveform that coming to this one? What is it? Is it really 36, the firing angle? Where is it? How do you want to look?
The firing angle, I didn't. We just assumed that I asked you last time, last week. You said I'd do this and this, and I just did.
No, I want to see the waveform like you see this is like a full wave, right?
Yes.
Yes, I want to see the output from here. Does it show like this one? Okay, maybe you don't understand what do I mean.
Yeah, I don't understand.
Huh? Okay. Because I want you to show like alpha equal to 36 right now.
Yes.
Or 36 degrees, all right? So T so this relate to 1/10 multiply by T, right? So it becomes 0.002.
Yes.
Okay. So I want to see whether you can show this waveform. Something like this, okay?
This waveform for it would be the output of the thyristors, right?
Yes, yes.
That before the permanent magnet.
Yes, yes.
Okay, maybe I can add another
Yes.
scope.
So that's mean you can see that, okay, this, but then the output there, you have to take the average, all right? The average.
Yeah, yes, the mean value.
Yes. But we want to see the waveform, okay? We want to see what are the waveform that coming into the machine,
Magnet.
all right?
Yes.
Which is the output of the thyristor.
Yes.
Which is the waveform should be like that, all right?
Okay, doctor.
Okay.
I will add.
Syakir? Haikal lambat Second time you lambat ni.
Haikal has
Sorry
internet
sir,
issues.
saya tak boleh nak connect pakai laptop je.
Kenapa?
Net lembab.
Internet tu.
Yes, he said he
Dia
has
pakai phone.
internet issues.
Sekarang ni dapat penjana kan? Have you applied for this one? Well, it's not penjana, the one that for the students, right? They got this. You can get free, or if you are B40. Anybody here B40?
Saya sir B40.
Siapa?
Saya
Syakir Dapat tak?
Saya sir, Syafiq Aikal.
You dah minta?
1.5 tu
Yang ada boleh dapat free handphone ke apa tu kan?
Oh tu dah pakai sir, tu lah. Sama phone yang boleh.
Apa?
Tak boleh nak connect ke? Dekat apa ni? Hotspot pun lambat juga je.
Syakir, you dah dapat tu? Dah minta ke belum?
Dah dapat.
Dapat?
Dapat.
Dapat handphone apa?
Bukan iPhone saya, dia bagi RM15 je.
Tak, ada yang handphone kan yang paling baru ni kan? Ada kan?
Saya tak pasti.
Yang untuk
yang
student
tu
tu kan?
Dia pilih doktor yang jaga dengan pelihatan boleh pilih dua. Sama ada doktor nak tolak RM15 bil ataupun doktor nak beli phone sekali dengan telco. Doktor
Alright,
boleh pilih
okay.
dua tu.
Jadi kamu ambil yang RM15 sebulan Syakir? Yang ni yes Yang yes ke?
Kan, dia semua ada.
Jadi kamu dah minta semua dah? Dah dapat? Ataupun minta yang kena pilih?
Minta
Macam
yang
tadi tu siapa cakap kamu dapat RM15 ni macam mana? Data ke apa? RM15?
contohlah bil Selcom RM30 kan. Kalau doktor tu dia akan tolak RM15. So doktor kena bayar RM15 je lah.
Okey.
And satu IC satu nombor.
Lagi satu yang dapat free handphone tu?
Itu kena pilih doktor. Sama ada doktor nak tolak RM15 satu bulan ataupun doktor nak beli phone sekali dengan telco. Kat situ doktor akan dapat kena tolak RM300.
Okey. Alright. So dia bagi pilihan lah.
Dia bagi pilihan.
Kamu dapat? Siapa dapat lagi?
Saya dapat doktor.
Okey. Cepat permohonan dia cepat
Cepat je macam sehari macam tu je.
Yang
Masukkan IC.
UTM punya? UTM punya peminta tak? Tak ada
Tak ada.
Dulu ada kementerian buat tu, kementerian siapa buat Sebab ada sudah komplain lah kan, sebab diorang nak bayar yuran mahal. Lepas tu sekarang tak duduk kat UTM, pakai internet sendiri. Tak tahu lah UTM dulu ada skim ni kan. Skim B40 ada tak? Dulu kan dia ada bagi macam, dia bagi rebate kan.
Ada Selcom. Ada. Selcom. Dia bagi Selcom dalam 2 bulan, 3 bulan.
Okey. Sekarang tak ada masalah internet Saya tengok Syakir okey je internet kan? Syakir pakai data ke pakai Unify? Syakir?
Wi-Fi je. Tak okey kat ni saya nak hujan ni.
Okey, alright. Syafiq, Hakan? Macam mana?
Phone je ni sir, internet phone ni.
Kenapa? Susah
Wi-Fi dekat laptop ni pun tak boleh nak connect Webex-nya.
Okey, tak apa. Alright. So, siapa nak present tadi? Yusof already present, right? Yusof, you are doing Syakir ada kena present.
Shakir cannot present.
Syafiq Haikal can, because Syafiq Haikal cannot, maybe they can show the file
Maybe you
to
can send me
somebody.
the file. I will
Yes.
share. This is the form you asked for, Doctor. Wait, I will share screen. I added the scope,
Alright,
the output,
okay.
and we run.
So can you see?
This is the
Okay.
scope, yes.
Yes. But now, why? There is a there. You shouldn't
is the
cross the
for firing
zero,
angle.
right? Negative.
Negative, I think this is the extension angle, I think, Doctor.
Huh? Okay,
This is the
extension angle.
extension
Okay, because of the
yes.
inductor.
Yes,
Alright.
because yes.
And then what you should do, you should put the freewheeling diode. Alright?
Oh, yeah, I have to add it too. Yes.
Yes.
To
And
remove
then we
this.
can see that the output, okay, you eliminate those things. Okay, that means you have to
Okay.
show. That
Okay.
means there is a evolution with your results. Okay, the result you first without freewheeling diode, and then you put freewheeling diode. Alright.
Doctor.
So you learn about this one, right?
Yes, we did in
Yes.
power electronics course.
How about the drive? Have you take the drive course at the moment?
Which drive course?
I mean the topic on the DC motor drive.
Yes. We already finished.
Already finished. Okay.
Yes.
So you got another 4 weeks, right? Now we are week 11. So very
Yes.
fast. Time very fast.
Yes.
And then this Wednesday there is no class, right? You know this Wednesday is public holiday.
Yes.
Research day.
Yes. Public
Yeah.
holiday.
I tell my friend, okay, you just tell your lecturer, all right? Maybe
I
they
already have
forgot.
no classes on Wednesday. Already have no classes on Wednesday.
Who told you?
I don't have classes in my timetable. So
all right,
already
okay.
public
Let's say you
holiday.
have a class and the test, and you know that you are not allowed to do. We are not allowed. The lecturers are not allowed to do the test this week and next week. Correct?
Correct.
For the PKPD, all right. We try to minimize the burden for the students. Okay. So just tell your lecturer, okay? Just tell your lecturer. Okay, like last time the lecturer do the test on the 15th, one day before student can go home. Also, they have to cancel the test, all right? Because some students are in the bus going back to their hometown. How come they take the test, all right? So you are doing this one. How about Shakir?
Shakir, you can present.
Shakir, you want to present?
Sekejap je,
The
saya tak boleh buka
separated
lab.
Okay, tak apa. So
Yeah.
I think you are almost done, all right? You need to do the touch-up for this week, all right? So compare project 3, compare to this lab to the other 2 labs you done. Is it this one is okay?
Okay.
All right, okay. And I'm quite surprised because some of you, when you do the simulation, you don't have any error. My final year students, okay, when they run the simulation, they got error. So I have to teach them, look one by one the code, all right? And then they simple mistake, all right? But I'm quite surprised how you managed to do this, okay?
I just copy from slides.
Huh?
I just copy from slides, Doctor. The
Yeah, but
slides we have.
sometimes even you do that, sometimes it's not smooth sailing. Sometimes they still got some error. All right.
Maybe the continuous block was the one thing that's not in the slides.
All right. So have you decided for the LI? I think now you got the briefing, right? When to do LI? Yeah, I'm quite surprised. One my previous student, they contact me. He contact me. Can I do LI under you? Because now, because of the PKP, maybe like last time student do the LI with the lecturer. All right. All right. So have you keep in touch with the company or what? For
Still
the
apply.
Ikman. Huh?
Still
Shakir?
apply.
Still apply.
Yes.
To do it. All right. So you are in Subang Jaya, right? Shakir?
Ah.
Subang Jaya got so
Apply.
many companies.
Hmm.
Last time when I visit my student, I think 2 years ago before PKP, I always visit my student in either Subang Jaya or PJ or in Shah Alam. I stay in Shah Alam. All right. So there are many companies in Subang Jaya. Maybe you can try very nearby to your home.
Yes.
All right. If not, you have to. Some students they delay. They do the final year project and then they do the LI. All right. You should do the LI in 3rd year, but I don't know now what will happen because the PKP that means now the PKP only 20%. 30%. 30% is it? Or 20% for the government only in the office. The other 80 for the company, I think 40%. So 60% at home. So maybe it's very hard for you to find a placement for industrial training. All right. So now I think I want to divide you into 2 groups. So what you are planning to do now before we divide?
freewheeling diode.
Okay, you add a freewheeling diode, the group 12, right? You add the freewheeling diode, and maybe Shakir also. You are doing permanent magnet. One of you doing permanent magnet and separate excited, right?
Yes, sir.
So later, I want to see the results. Which one is better when you using the rectifier or the one that using the switches? Maybe the result is still the same. All right. Okay. So the group 8, maybe you can put prevailing diode as well. So you can do the Yusuf one, the Yusuf that showed me just now. You should also put the output from the switches. All right. Do you understand?
No, not
Because last
exactly.
time Yusuf showed me the input to the motor is the output from the rectifier.
Oh, alright.
Right? So we want to see what is the effect of those because when you do the with the switches, there is no firing angle, right? Is it more on the duty cycle? How do you determine the output? Why can the output the voltage can change? That means you can change the speed. So how do you change the voltage? Like the Yusuf just now show us, for the rectifier, you can change the voltage by changing the firing angle, right? Because the output of the rectifier is become the input to the motor. All right, they are related by the V out equal to what? Is it 1 minus cos alpha V in, something like that? There is a function of cos, right? Is it correct, Yusuf?
I think it's V max divided by pi cosine alpha.
Yes, okay. All right. So for the gate, right? For the switches, how do you want to determine those? Do you understand? Okay, I give you one hour from 2:30 to 3:30 for you to look back on the lab sheet. You got the lab sheet, right? So what you need to do extra? Maybe you just need a touch up and then you can write the report. All right? Can? So I divided, okay, I will do a record session. So I will do the record session 2. So assign. Okay. So I put Yusuf, Shakir, and Ikmal. No, it's going out now. Haikal, is it here? Okay. And then I put Ikmal, Imran, and Firdaus to the breakout room 1. Okay. All right. Okay, Shafiq. So you join group 2,